Hello. Everyone get the dependencies installed okay? Everyone has Python? Yeah.
I just downloaded it and installed it.
That's good.
And I tried to pull it up and I have no idea.
That's okay. Did you get, hello, sir. Did you get Bash installed?
No.
Okay. So let's do, yeah, this year. So if we go for hit Bash. So that's going to be a little bit different terminal prompt. Just cross Python should work.
Tennessee.
How's things?
It's been busy.
Yeah, you betcha.
You know, to see if you've also been busy.
Always. Always. Hello.
This is the R Study Group, right?
It sure is. You're gonna do Python today, but you know, whatever.
Yeah, no.
Yeah. Okay. Did you get the dependencies installed okay?
I did not see that.
Do you have Python on your computer?
I do.
You should be okay.
Bill, when I go to the third pad, I'm getting a 400 error.
That's not good.
No.
That's not cool. Let's see if I refresh
Yeah,
this.
400 bad requests.
Works for me.
It's working for me. Yeah, I'm wondering if it's because I'm on the UBC.
Oh, I'm on Visitor as well. network is always the hardest part of the computer. Let's see here. What could possibly go wrong, right? That seems reasonable. What browser is this? You think it's 0, right?
Weird.
I don't know what to tell you guys.
Yeah, I had a problem with something else too, so I wonder if it's. I don't know. Oh, you know what? I'm gonna just turn off. I wonder if it's like a firewall. Because I tried to get into something else.
There's a zillion different Etherpad services out there, so maybe next time we'll use a different one.
Well, no, I
Besides
mean,
firewall drama.
yeah, it's probably.
There's one extra dependency I'd like you guys all to install before we get started. I forgot to list, sorry. So we're going to use nose for testing our code calls, or so just before we actually get started in earnest, people are still installing a couple of things. If at your terminal prompt you do nose tests -- version, it should hopefully tell you something. I don't actually really care what version number it is, but just have it. And if it is not there, you can probably do sudo pip install nose. Hopefully get it. So we're going to wait a couple more minutes for people to trickle in. Welcome, have a seat. We'll wait a couple more minutes for people to trickle in and just have a go at that. Well, wait. So this is your DOS. So you get dip bash and stuff. Okay, let's fire that up. So the difference is because there are so many programs, but just put syntax. Double click on that thing, that installer.
Yeah, that's nice.
Go back to the website about that instruction. So yeah, we click on get bash to see if instructions there. So that's what that thing. So you look for that. I'll see if I can find better instructions. Let's see here. Okay, we're going to have to work together with someone else that can either help you find it or you team up on your machine and see how this goes. Joey,
Yeah,
why don't you come buddy up over here? That's okay. That's what we're here for. So try to install Good Bash. It's somewhere out there. I have no idea where. So we can either find it or team up and everything. Oh, is that? Hey, yeah. Okay. Try typing Python Python space dash minus. Still looks like DOS actually. Yeah, so we're good. Okay, everyone, we're a few minutes after the hour, so let's get started. First of all, Happy New Year. Welcome back to our first demo session of 2016. And today we're going to learn about making packages in Python. Before the break, we started a few Python lessons. And one question that came up for people was, what is this dot notation? You often see stuff in Python that looks like numpy dot, I don't know, array or whatever. Maybe there's some brackets. Or what are these periods supposed to be? That really confused people before the break. So I think a lot of people in this room have like an R background. And correct me if I'm wrong, but I think in R, you can just put periods wherever you want. It doesn't really matter. It's just, yeah, that's right, yeah. So they don't really mean anything.
Sort of.
Sort of. Okay. Okay. So I don't really know R, so I don't know. But then, so they sort of don't matter, but they sort of do in R. But then the Pythonistas get all really uptight about where you put your periods and stuff, and it's a big problem. And that really confused people. So what I wanted to do is give a lesson to try and address those problems. Hello, Andrew. Thing is that I have been to and given literally a million lectures on things like encapsulation and object orientation and inheritance, and I call that stuff like the classic rock of programming, right? It's really good foundational stuff, but it's way, way too abstract for a first lesson on this kind of thing. So instead of doing that kind of stuff today, what I want to do is work with you to build something that will illustrate the meaning of that notation and give you a foundation to maybe learn about those ideas in a future lesson some other time. So what we're going to do is learn how to build packages in Python. Okay, so hopefully we all have Python installed, ready to go. One thing that's going to be different from our previous Python lessons is we're going to turn the clock back. We're going to pretend like it's like 1970. We're not going to use the IPython notebook. We're going to do everything in scripts, so plain old text files. Use any text editor you want, doesn't matter. That's how we're going to build stuff today when we're building packages. So to start with, let's warm up by writing some Python. Remember what we did last time. Like I said, from your bash shell, maybe go to your desktop. It doesn't matter, just wherever you want to be in your bash shell. Let's open up a file called, I don't know, analysis. Again, and it with .py when we're writing Python. So we're going to write some Python. Who remembers how to write a function in Python? What do we start with? Like the leopard, like the tone. Def, that's right. We're going to define a function, and then the first thing that comes after that, yeah, like the jam, exactly, is the name of our function. So let's, I don't know, let's convert like, I don't know, Fahrenheit to, I'm not even going to try to spell Fahrenheit, to Kelvin. What comes after the name of a function? Holy soon, yeah, but there's one thing first. You remember? Inputs, yeah, so in round brackets like this, I want to plug in a temperature into this, so maybe I'll call it temp, like that. Okay, is there a question here?
No, I just can't get to the, I don't know.
Oh, okay, so.
It's fine, I can see what's going on.
Okay, but you can group up with these three as well,
Okay.
and sort of get involved in
Okay.
Yeah. Okay. Anyhow, so what is the first thing that goes in every single function in Python we ever write?
You write VI, you got it.
What do I write?
VI. I don't think Nana comes
Maybe not. So yeah, try VI or Notepad if that doesn't work for you. You just type Notepad at the bash prompt. That'll hopefully go. Hello, welcome. We've just started. So we're just editing a text file right now. That's all we've done so far. Copy that down, you're good to go. Okay, so like I was saying, what's the first thing that goes in every Python function we ever write?
Always, all the time.
3 hash,
After an indent, right? But yeah.
and then whatever.
And so what is this? This is a description of the function, right? We always write a little piece of documentation to explain what this is. So I'm going to take a Fahrenheit temperature and return it as in whatever it is, Kelvin. So we remember 6 months from now what the heck this is supposed to do. Okay, so let's see, who remembers how to do this? Let's assign our Kelvin temperature to a variable. What is it? It's like 5/9 times, I think, the temperature minus 32.
30. Oh yeah.
Well, yeah. And then plus, so that's freezing if temperature is 32. So then you have to add on like the Kelvin freezing temperature. And I'm going to add it as a variable like that and just define it out here in case I want to use Kelvin's freezing point somewhere else in my program. What is it? It's like 273.15 or something like that. Yeah. Okay. Now what's the last thing I need? Is that wrong? What? Is that something else? No? We're good? Okay. It's been a long time. What's the last thing I need in my function? Return, or give an answer back. So that's going to do a calculation. Now we want to actually return that. That make sense to everyone? Does everyone understand every line there? It's not nothing surprising or mysterious happening yet? Okay, we've written a function.
Just a quick question. You have 5 point. Is that just you did put the 0 afterwards?
Ah, yes. If you absolutely can put zeros there. So the thing about Python 2 is that if I just did, that'd be 0, right? Because if you put integers into division, it spits integers out, and it's best guess. It always rounds down to 0. We don't want that. We want actually 5/9. Yes?
Did they change that?
Yes. In 3, they smartened up about it because that was kind of bananas. Yeah, that caused so many problems. So, okay, feels good. Actually use our function. If I go far to Kelvin, oh, actually, hold on. Let's actually print something. I print far to Kelvin of, what's boiling in Fahrenheit? Like 212 something. Save that. I'll bring this back in just a second. Then I go Python, to run my Python at the command line, you type Python and the name of your file. Aha, 373.15 Kelvin. Cool, it worked. So let's bring that back. That's what we have so far. Makes sense? Everything works? Question from Andrew.
How does it know that so Python is all about indentation, so it knows the function's over because the indentation goes back to being all the way to the left.
That is a good point. I should have called that out. Exactly. When we want to be done with our function and do something outside of it, we go back one set of indentation. I like 4-space, or I guess I did 3-space indentation here, whatever. As you can see, it doesn't matter. You don't even have to know how big your indents are as long as it's always the same. That's the only thing that matters. Okay. Okay. Great. We've written some Python. It seems to work. It does its job. This is such a great piece of Python that we want to take this and wrap it up in a package so that we can use it later, use it somewhere else in our future projects, or share it with our colleagues, have them use this stuff. So anyone who's written Python before, you don't have to copy this part down, but you know how a lot of Python programs begin with like import numpy or something like that, right? Or you import stuff and then you can use that right away in your program. We want to be able to do that. We want to be able to import things and use our far to Kelvin function or whatever other functions we defined in a later project. So that's our goal, is to get there. And to do so, we're going to make our first package. So to do that, let's get out of this text file. Now let's make a new folder for our project. Let's call it My Project. Well, let's go in there. And then inside our project, let's make a directory for our package. So I'll call it My Package. And then in last step down the rabbit hole here, inside My Package, let's make a file called My module.py like that. So to recap, that's what my directory structure looks like. From the desktop, I made a directory My Project, then I made a directory My Package, and inside that is a file called My Modules. Questions? Okay, so we're just setting up our workspace here. Inside my module is where we're going to put all the functions and variables that we want to package up in this package and share with ourselves in the future or with our colleagues. So let's go grab that from our, where am I right now? Let's go grab that from our original, oh, you probably can't see that. Move to the top again. We open up our original thing that we made. Let's copy the function and this variable definition here. Let's grab that and then go back into it's project, right? My package, which has my module. Go back into my module and stick that variable and function definition in there exactly as it was in our original scripts. Cut and paste it in there. Okay. I'll slow down for a second. Remind you of the directory structure here. There, looks like that. Yeah. Okay, makes sense? Okay, once we've got that, we need one more file to turn this into a package that Python can recognize. So right beside my module, inside my package, let's make a file called init.py. And that init is surrounded by 2 underscores on either side, right there. And the point of this file is it's going to help tell Python what to do when we try to import our package. So make that. We'll open that up. Remember, 2 underscores around it. And then in there, we're going to give it some instructions on what to import. So to import dot, that means from right here, import, I think it's going to be my, let's see, we're inside my package. So import my module, like so. Inside your init.py. Let me make sure that's actually right. Yep. That's what our directory structure looks like right now. Just to make sure everyone is keeping up here, what I'm going to do is put every code that I'm writing into the Etherpad that if you look on the issue is linked right here. So if you're falling behind and need to cut and paste the stuff to catch up, I'm going to throw this into the Etherpad. So here's init.py. There we go. So underscore init.py is this. And then my module .py is, again, stuff. So like I said, if I'm switching between screens too quickly for you, head on over to the Etherpad and you can cut and paste our scripts from there. Okay, questions, comments so far? Good, because we're done. That's pretty much. Oh, wait, Andrew has a comment.
I'm going to come up with one for you.
Okay, what's up?
So init.py has to have a certain name that's got to be preceded in an end, but with those 2 underscores. Does the my module have a certain name, or could it be called anything?
Anything you want.
Okay.
Just the init.
Does it have to be called my module?
No.
Okay.
Anything prefixed with my is probably an example. Could be anything you want. Yeah.
It's also mysterious.
Yeah, kind of. But yeah, no, the underscore init .py is the only strictly formal name in this structure. So, question?
Can I ask, just basic,
Yeah,
you must have explained already. How do you switch back from the Pico to the terminal?
Control X. Yeah, it's not obvious. There's a list of instructions probably at the bottom, but it's not. It's just like a little caret.
Yeah.
That means hold down Control and hit X. not
Not
obvious.
Make a carrot.
No, which is a pretty fair guess, actually. Yeah, there you go. Control X to get out of there. Okay, so like I was saying, if we're all caught up to there and that all makes sense, that's great because we're pretty much done. We now have importable code. If we go back down to the My Project directory, and let's make a Python file called like, I don't know, let's call it analysis. No, I think I always call it analysis. Analysis.py. And I go import my package, just like we wanted to do. And then I go print my package dot, what I call it, my module, probably going to spell this wrong, far to, I call it Kelvin, like that. And what do we did the boiling point of water at 212 Fahrenheit. I think it'll work. It might work. Try it. I'll come back to this in just a second. Make sure it's actually right. Oh, you can't see that, can you? Let's get that back to the top of the screen and go Python analysis. Oh, whoops, daisies. It's mad about my init file. So if we go back into my package and open up init. Oh, whoops. Haha, that's totally wrong. Don't code from memory, folks. From here, import my module is actually what you want there. So to read that, that's from right here. That's what the dot means. Import my module. So I'll put that in the Etherpad if anyone wants to cut and paste it. Let's try again. Back down to project. Go back to the top of the screen here. There we go. Okay, fine, good. Okay. We get the init working properly. Then we actually get the result that we wanted. Let's go back into analysis.py in case you didn't have a chance to copy that down. And we got exactly what we wanted. I imported my package, and then I used the function. And I did not have to cut and paste my function or anything like that. I also have access here to the variables that were in my package that I totally don't remember what it was called now. So let's go look. I called it Kelvin freezing. Cool. Kelvin spell it right. Freezing. Like so. And do that again. Python analysis. And it spits out the freezing point as well. Point being is that we have access to both the variables and the functions that are defined in that package. Cool, right? Reusable packaged code that we can write once and never, ever, ever reinvent that wheel. It's super useful. Questions? Comments?
Does it matter where the analysis files?
In this case, yes, because we haven't installed this package yet. We've just written the minimal amount of stuff to make import actually work. We're gonna do more stuff in just a minute to make it so that you can install the package and use it from anywhere, just like you can import NumPy or whatever from anywhere. So we're not there yet, but we're gonna fix that problem. Okay, feels good? Hopefully, this answers the question that we wanted to start out this lesson answering, which is, what does this dot notation mean? Well, now we've built something together that illustrates the hierarchical nature of what this dot notation means in Python. My package has something in it called my module. And so I say what this dot notation means is like, look inside my package for something called my module, then go look inside my module for something called far to Kelvin, and then pass that 212 to it as an argument. Same deal, exactly the same logic for this variable. Look inside my package for something called my module, look inside my module for something called Kelvin freezing, and then print it out or whatever. So that's what the dots mean in Python. That's why it's such a big deal about getting your dots in the right place when dealing with Python packages, is because they indicate who belongs to who in Python. Make sense? Seem good? Yeah? I'll cut and paste this into the Etherpad as well. Like so. Okay. Cool. We successfully wrote and imported some code. But as Will has already alluded to, there's more to making a package than just being able to import some code. We want to be able to install it and wrap it up and ship it places and that kind of thing. So for the rest of today, we're going to go through the other little bits and pieces that go into making like a formal package like NumPy or like anything else that you would get off pip or whatever package manager you choose to use. So other stuff that we need to have in our package. Once you've written a function and you want to make sure it works correctly, what should you do for every single function you ever write in Python or any other language? Test. Ah, someone said it. That's right. Test it. Test it properly. So how we set up tests in Python is make yourself a directory. Oh, actually, hold on. Where are we? We're in my project right now. And make yourself a directory, tests. Go on in there. And then make yourself a file called test.py, like so. And open that up. Wait a second.
So the folder for tests goes inside my package or outside it?
Inside my package. So here, I'll back up before I open that. So if I look at, or not, sorry, in my package, in my project. Yeah, I should have named them so similarly. Good. So you should see in, here, I'll get to the top of my screen again. Inside my project, you should have my package directory and tests directory. Okay? Yeah? Slow down for a second, let you copy that down. We don't actually need analysis.py anymore, so I'm just going to move it down a level. You can just remove it if you want, like RM analysis. We don't need it anymore. That was just to use it once to illustrate the idea of imports, but normally we would not actually use the code inside the same package. We want to make the package, wrap it up, and then go use that somewhere else. Just like someone made NumPy and Matplotlib somewhere else, and then we use it in our analysis. Okay, so like I said, we've got a directory my package and a directory tests. Go into tests, we've got a file test.py, and in there we're going to start writing our first unit test in Python. So if we open that up, tests. First thing we need to do if we want to test our code is actually import our code. So if I go from my package, import my module, get that in there. Then we can write a unit test in Python in the exact same way we write a function. I start with def. Now we start the function names with test underscore, and then whatever you want to describe the test. So I'll say, I'm just going to test far2kelv. Here. No arguments for your test, colon, and then as always, a doc string, test nominal behavior. Doc string can be anything you want. Far2kelv. Same indents, close those quotes. And then how we write a test in Python is to use Python's assert command. So what we're going to do is assert that some calculation comes out the way we would expect. And so how I do that is I imported my module from my package, so I can call my function by saying my module dot, I think it's far2kelv, like that, right? And so if I evaluate this at 32, what should I get? What should the answer to far2kelv of 32 degrees Fahrenheit be? Yeah, what's that? Yeah, it's freezing, right? 32 Fahrenheit is freezing, and freezing in of freezing point of water, and that in Kelvin is 273.15. So if my function works correctly, that should be true. Everything should work. Question?
The other thing you could actually do, or I guess you could do it separately, is actually make it equal Kelvin freezing.
The variable that you had in, like, so you're suggesting you could do it like my module, what did I call it? Kelvin freezing? Freezing. So you totally could.
Unless it makes more sense to have test them separately.
It's an interesting and subtle point, right? Because they check slightly different things.
Yeah.
If you type in 273.15, I know I keep going back and forth, it doesn't matter which one, but whichever one you want. Maybe this one because it's shorter. If you put that, you're checking that 32 Fahrenheit evaluates to 273.15. If you put in the variable name, you're checking that 32 Fahrenheit evaluates to whatever you said somewhere else the right answer is. Subtly different. Tests are free. Might as well do both. But anyway, whatever. There's no need to write a million tests for this simple package. Let's save that and then get out of there. And from the My Project directory, if I do nose tests, this might not work for everyone because I didn't tell you to install nose. We'll take a minute to install it if needs be. So if I do that, oh, that's mad at me. Did I spell it wrong? Probably. What did I call it? Ah, yes, the function is far to Kelvin, not far to Kelv. Bugging folks. Far to Kelv in. Hopefully that works this time. Try again. That's what you get if it works. So it runs the test and checks that those assertions are actually true, and with no complaints, that's what you should get. If you are seeing something to the effect of, what is nose? I don't know what nose tests are. I don't have that command. Try doing sudo pip install nose first, and then that'll install nose for you. So take a break there. Who's successfully ran the test? A couple people. Okay, so I'm gonna stop and wait for you to catch up there. In where? Oh, it looks like this, and let's put that in the Etherpad as well. Nose is a test suite runner for Python. So it's a framework that will run all of these tests that you've written and report back whether any of them failed or not. So notice that for our test suite, we wrote a function, right? I never called that function. I never did anything with the function. I just wrote the function. And nose is what sucks those functions up and executes them and produces a nice little report for you about which, if any, of them failed.
Oh, so it's right. That's a function.
Mm-hmm.
It's so quick to create that I didn't realize that's what it was.
Python kind of looks like haiku, looks like poetry. After a while, it's very, very terse. There's a lot of white space. There's not, yeah, it is, but it's not always obvious what it is.
Like
right away. Yeah, exactly. It's subtle.
Can testing functions have arguments?
Yes, they can. So a more sophisticated way to build up a test suite would be to build a test class. And then a really common argument you would pass is, so this is way more advanced than we're doing today, but you pass the class to itself in one of its member functions so that if it had data on it that you set up before the test, like say for example, you have a more complicated function that you need some data to test its behavior for, some parameter file or something. You don't want to load that parameter file every single test. You can set it up so it loads the parameter file once and sticks it into every test that you run. Way too advanced for this lesson. We're not going to worry about that today. But the short answer to your question, Andrew, is yes. Any more people successfully ran the test? Okay, a couple more. Yeah, cool.
So do most Python packages ship with the tests folder in them?
Yes. And that is sort of the other element of this, is that there's a broader context to what we're doing here, right? The point of making packages in Python or any programming language is for sharing this code with our colleagues. Why, oh why, would you write a Python function to convert Fahrenheit to Kelvin? Again, why would you reinvent that wheel? I did it for you. Now you can just have it, right? But you know, who am I? I'm some random person on the internet. Why would you trust me? Why would you use my code and believe that it actually works sight unseen? Well, to develop those trust relationships and to make a quantifiable argument that, yes, I did my job correctly and my code actually works, that's why we write test suites. To demonstrate that the code actually does what we think it does. Not only now, but imagine if this project was way more complicated and later on I make a bunch of changes to this thing And then I want to ask myself, did those changes break my package? I don't know. Would I go through and check everything by hand? I don't have time for that. That's way too much work. But now that I have this automated test suite, I can, anytime I want, run the test. Yep, it still works. And apparently it takes less than 1 millisecond to do that. I may not have time to check things by hand. Even I have less than 1 millisecond to double check my code using a test suite like this. So that's why it's another fundamental part of writing a package.
And so can I just ask a mechanics question here? So test pi is in a subdirectory of my package, right? And
So
how does it know when you're saying from my package that my package is?
because I ran nose from the my project directory. So let's go into tests and see how miserable, let's see what a miserable failure this is. If I do that, it's mad at me because it doesn't know where the path is.
Okay.
It doesn't work and it shouldn't work.
So Python script, so nose is actually an instance of Python. Is that right? So like nose is a Python script or like Python package.
Yeah, I mean, it's a utility that knows how to run Python. So yes, I suppose it does invoke a Python kernel. It must.
From the parent directory that it's being
From
run.
wherever you're running from. So like I'm running nose tests in my project. Should I draw a picture of this file structure? Would that help?
No,
We've got a few minutes. I think I will.
I think I get it. I just it wasn't clear to me how to test Pi. So if we So if we just went into test pi, if we went into the tests directory, just ran Python test pi, it would actually.
So if anyone has lost track of my directory structure, I'm going to lay it out in the Etherpad here. So it was so my project had my package in it, and it also had tests. My package had what? Help me out. My module, Google. .py. What else does it need in the .py? And then tests had test.py like that. That's if you lost track of where all this stuff has to go. That's where it goes. It's complicated the first time you do it because it's like super picky, but like this has to go there, this has to go there, and that kind of thing. The good news is it is always exactly the same. That will never ever change. So you can copy that pattern forever when you're making your modules, making your packages, what have you. Okay, cool. We've written a function. We've tested our function, so we know that it works. What else do we need to do to make a package here? Well, good news is that we finished all the really technical crunchy bits of making this package. Now we have to worry about communicating this package to other people in the universe. So the first thing any good package should have, if it's going to be shared among people, is a license that define the terms of how other people can use this code. So in my project, I will always open up a file called, big capital letters, going to shout it out loud, license.md. Now, the thing about licensing is that the texts of these licenses have been worried about by lawyers around the world to make sure that this will hold up in court and make sure that it defends your copyright. The hard work that you just did. So you want to share it, but you don't want someone just stealing it and running away with it and never giving you any credit for it.
Unless you it depends on the license, right?
Fair enough. So I'm not going to go into like a big long discussion of like different licenses and what they mean and that kind of thing. I leave it to you to peruse the discussions on the internet about what sort of licenses are available. For me, I choose to make my life easy, and I always just use the MIT license for all my code. And to use this, it's real simple. Cut and paste that, and I'll put this in the Etherpad in just a second. Cut and paste that into license.md, change the copyright to your name and the, I guess it's 2016 now, the appropriate year, save that, and you're done. MIT license says in plain English, anyone can do anything they want with this code, but I am the copyright holder, just because I'm the one that originally wrote it. Again, we don't have time to go into all the myriad different licenses that are available out there. The point is, put a license on your code. The corollary to this is people often want to make open source code, and they think that the most open they can be is to not put a license on it at all. Wrong. This is absolutely not correct. You go on down to the IP office here at UBC or your legal team at your lab or whatever and ask them what they think of you using code that doesn't have a license on it and watch the look of horror come over their faces. The trouble is that when a license isn't defined, it's not free, it's ambiguous. And that means like legal teams are going to get worried about like what landmines could there be in the future. When you put a license on your code, there are no landmines. It's very clear what the terms are.
And it matters sometimes for businesses how they license it because there may be responsibilities. So if they license it under certain licenses, they may
Yeah.
liability.
And that's why I like the MIT license is that there are 0 liabilities under MIT. So anyone can do anything they want and not be afraid of using this code. There will be no ramifications. That's the point. Anyway, like I said, we can spend a whole hour just talking about licenses. I'm not going to do that to you because there's other stuff we need. One question. Oh, sorry. Let me put that in. What was in license? Yeah, it was the MIT license that I put in there. Like I said, you do not have to use the MIT license, but just for this example, I lost my Etherpad. Let's get back there. So license goes in the top level here. Nope, not that. Nope. Damn it, Etherpad. There we go. License.md, and then that file has, a little chaotic, but this text, which you can, woo, that's weird.
Yeah.
Okay, well, take the white space out. But the point is that's the text of the MIT license. But again, do not feel obligated. There are BSD licenses, new licenses, Apache, all kinds of different things. I don't want to give them short shrift, but we do have other stuff to cover in this lesson. Okay, cool. That's our license. Everybody now knows the terms of using our package. Something else that we need to make sure people understand what our package is about is, of course, a README. So the other thing that should go at the top level of your package is something called readme.md. And I like to shout that one out loud so people notice it. And then in README, again, I could do a whole hour lesson on good stuff to put in a README. Instead of doing that, I'm just going to write a meta README that describes what should go in here. So abstract of the project.
Does everyone know that an MD file is
No, okay. So, all right, fair enough.
I don't know. I mean,
okay. So if you're not familiar with Markdown, that's okay too. You could just do readme.txt, like a text file, if you're more familiar with text files. So they're both just plain text, right? The special thing about MD, Markdown files, is that they give you a syntax that will let you do pretty formatting on the web. So like, you know how like issues on GitHub, for example, they look kind of nice, they got headings and stuff like that. You use Markdown to create that. The reason I wasn't too worried about explaining it though, is that you can't get it wrong. You can just type plain text and not know anything about Markdown syntax in a Markdown file and nothing bad will happen. It's fine.
It's just text.
Yeah, if you want, it'll look pretty on the web. But if it sounds like too much trouble, don't worry about it.
it's like the same kind of format.
Yeah. In a README, I like to have topics like the abstract of a project, really short, what's it about, usage instructions. So like, how do I use all the functions and stuff in here? You know, the things you would want to read when you come to a new package, like how do I use this thing? What's in here? That kind of stuff. Contribution guidelines. So if someone wants to contribute to this code and has a suggestion for you, what way do you want people to contribute to your code? Do you want them to email you? Do you want a pull request on GitHub? Should they, whatever, it doesn't matter, it's anything you want. Like I said, that's a whole other lesson of how to write these. The point is use the README to describe how people should interact with your project, both using it and contributing to it. Cool, there's our README. And then the last thing that we need to make a formal Python package is one last file that describes in a machine-readable way what all the little bits and pieces of our package are. And in Python, that's called setup.py. So I'll go nano setup.py. And that, here, I'll go back to my, before I start typing that out, I'll go back to my thing here. And so alongside license is readme.md, and then also we're going to have setup.py. I'll just put a note. I'm not going to cut and paste the content of my readme in here because it's just sort of meta, like I said. So good, I'll put a note here. A good readme describes how to interact with the code, both using it and contributing to it. So that's in the Etherpad for future reference. Okay, cool. So like I said, the last thing we need here is our setup.py file. Oh, whoops, that's not what I wanted. Which I have an example of in the notes, and the link to these notes will be in the issue afterwards. Grab this, and then in setup.py, again, put that in there. And so this is importing a few tools for making packages. And it's just always the same. That's just boilerplate, that first line. Right here, I guess I'll put this in the Etherpad for you as well, so you don't have to copy all that out, because that's a little bit too much to copy. There you go. And then change the variables to be whatever you want them to be. And to go through those variables right now, you can give a name to your package. What's this package called? This is our Python package example. What version number do you want to assign to this? And there's lots of tutorials on the web about something called semantic versioning that will help you choose an appropriate number for your package. I usually start with 0.1.0. That usually indicates something is ready for other people to look at, but maybe not fully ready for prime time yet. Still needs some work. The next command tells the package creator where to go looking for your package directories, and this command will wrap up every subdirectory as a package except for tests. Tests are not their own package. Tests test your packages. So in other words, just copying this line exactly will always wrap up everything that you've made in a subdirectory as a package. So I never have to change that. What license will you use? I used MIT. You can give a short description of your package in the description field. A longer description, you could type out an explicit description here, but I usually like to just refer people to the README that we wrote in the last step. So we don't have to maintain a whole bunch of different things. If we have any dependencies, and this is where this gets really useful and important actually. If we have any dependencies for our package that need to be installed before our package, we can list them here. So this is a little bit fake in that we don't actually need NumPy for this package. But if we did, I could list it right here. And then when pip tries to install our package, pip will say, okay, wait, hold on, but do I have everything in the install requires field? Do I have NumPy? Yes, good. No, then I got to install NumPy first and then come back and install this package. So it deals with your dependencies for you really nicely. And you can add them in a comma-separated list. If I needed matplotlib, I can add it in there. Anything you want, any package under the sun, just add to that list. You can give a URL for a website for your package. Most commonly, this will be the GitHub repository that you're keeping this code on, or maybe you have some documentation website, or maybe it's your personal homepage, doesn't matter. Any website you want to give people more information about this. Who wrote this? I did. And what's their email? You can give an email for contact information if you want. That personal identifying stuff you may not want to include. You do not have to. It's not obligatory. But if you want people to be able to contact you and participate in your project, that's what that's there for. Question?
It's not a question. One thing I've seen people start putting in recently for packages and stuff, there are codes of conduct that you can get online.
Yep.
And I really like it. I think it's a great idea. And if you just type software code of conduct, you can find it. It's an extra file, often in Markdown.
Absolutely, I couldn't agree more. Codes of conduct are really important elements to maintaining healthy online collaborations. It's really easy to be rude to people on the internet. It's really easy to forget that they're actual people. Everyone's been there and experienced that. It's terrible, right? That's no way to have a healthy scientific collaboration. by laying out some ground rules. Even if those ground rules seem kind of obvious, the real kind of meta point of a code of conduct is to remind people, hey, don't be a jerk. You're going to participate on this project. Respect people that are participating with this, and remember that we're all humans here.
And laying out those rules at the beginning gives you an ability to fall back and say, okay, this has gone off the rails.
Yeah.
We've already made our intentions clear.
Yeah.
And so,
Yeah. Having something to point at to say like that behavior is inappropriate because of X, Y, Z helps you actually make an argument when you have some toxic community member, which will happen on the web, unfortunately, and you need to tell them to get lost.
They're starting to do that in like elementary schools where they have a code of conduct before they even start the year and they just sign it.
Oh,
So they should have done that a long time ago.
yep. That's a great idea.
And at conferences as well now. So I think that use our conferences. Just last year, there was a big push to actually say, okay, at this conference now, you're going to have an official code of conduct so that in case there are issues,
Yeah.
we have something to fall back on and say, okay, look, we made this clear.
And I think it makes sense when you know and doesn't do that. It just reminds people that they're in a public space and behave themselves.
Exactly. That reminder, right? That that we need to treat each other well, because things got ugly at conferences for a while there. People were just not behaving like
all conferences.
yeah, just all conferences everywhere. That people were just not behaving like humans. So yeah, those sort of reminders are super valuable for creating a healthy community. More ideas? More questions? We're almost done. We got one last thing to do, and we're gonna wrap right on time. Going once, going twice. More questions, more comments. Okay, so we're done. We've written all the things that we need. Maybe we add a code of conduct as well. So let's actually not just talk about it. Let's actually do it. Nano code of conduct dot md. Describe to people your standards for respectful interaction. That sounds like a lot of work to write. As Simon correctly pointed out, there are 1 billion of these on the internet that you can cut and paste and use at your discretion. Okay, so the last thing is to wrap this up into a package to address Will's question from long ago of how do we make this an actual Python package that we can install and use, just like we install and use NumPy, not just from the My Project directory, but from anywhere on our machine. And now that we wrote the setup file, we should, I hope it works, setup.py, should be able to do that by typing python setup.py sdist, which is for making a distribution of our package. Chug, chug, chug. You get a whole bunch of stuff. And if I list this again, I have a new, here I'll get to the top of my screen again. I get a new dist directory. If I go into dist, I've got a wrapped up package of the code that we have just written together that I can now put onto PyPy. So I'm not actually going to do this because I don't want to spam PyPy with like 1 million demo packages, but how you would do that is go, and again, like, don't actually right now. Do this on your own time when you have a real package you want to put up there. But you can go python setup.py register. Not actually going to do it. And what that will do is look in your setup.py for the name. Where am I here? Oh yeah, I'm in dist. So look in setup for the name of your thing, Python package example, and it'll check on PyPy. So everyone knows PyPy. That's when you do, when you do pip install some package, it's going to the Python package index, PyPy, to go and download that package for you. So it's like CRAN if you come from R. So it's Python's equivalent of CRAN. So it'll go to PyPy, make sure that name is available because they all have to be unique. Hear you. And reserve that name for you. And then if you do, after you've reserved that name, if you did Python setup, well, that's sort of like Python, Python setup.py sdist upload, that will push your package that you just made in that dist, that .tar.gz, push it to PyPy, and it's there for the whole world to use. So like I said, I'm not going to push my package right now, but I did do this once to make this demo example, so when we can all try this next one. If you do sudo pip install Python package example, it will ask you for a password. Who am I? Like that.
If you're in Windows.
Okay, yeah, so if you're on a Windows machine, no sudo. It'll install that package for you, and then you should be able to make, here, I'll get to the top of my screen again. Should be able to make analysis, or like analysis 3 or something by now. I should be able to import that. Now that I called it my package, I think. I can go print. Where is this coming from? I would go read the docs that I wrote in my README for this package that I shipped. I think I called it, sorry, it's a little bit different. I called it python.far. It's the exact same code. I just called the function and module something a little bit different, but it's no different than what we actually did. What were we doing? Boiling point? Hopefully that works. Python analysis 3. Oh, no, it's mad. Okay, so maybe I called it something different. But anyway, whatever. The point is that by going through those steps of like Python setup.py sdist upload, that's how you finally wrap up your package, get it on PyPy, and use it. Let other people use it out there in the world. And then it'll stand alongside giants like NumPy, Matplotlib, Pandas, and all the rest.
So does Python have any, so with R, when you upload the package, there are a group of people who actually look at the package and say, yes, this can go up. Does Python have the same thing? Or
Nope.
sort of gatekeepers?
Nope. There are no gatekeepers on PyPy, which is actually a really interesting point. It is the Wild West. You can put anything you want on PyPy that you wrap up in a package like this. And it's a really interesting difference to CRAN, right? CRAN can be really hard to get stuff on. Those rules can be really, really strict. And they're strict for good reason. I get why the CRAN maintainers want to do that, because they want to maintain a high standard of code there, so that when you get something from CRAN, you are assured that it's going to be of a certain minimum quality, which is awesome. That's really, really great. I get wanting to preserve that usability. The other side of that coin, and the side of the coin that PyPy serves, is that a lot of scientists are scientists first. Programmers like a distant second. Fighting with CRAN maintainers is not what most researchers want to spend their time doing. And so that barrier is just going to result in code not getting packaged and not getting shared among people. And so by creating a completely open package management system, Python removes those barriers, so it's easier and less time consuming for you to share your code as a package, which I would really love for you to do, because I hate it when people reinvent wheels. We do not have time for that.
Is that what people have packages non-CRAN generally? Is that the one
It's- I mean, I'll say I have one package, and it wasn't that bad.
Yeah.
I mean, we got it out the very first try, but that's because we used dev specific dev.
Yeah.
Great. Some people have great experience getting stuff on CRAN. You got it in one try? That's awesome.
There's some good blog posts that sort of go back and forth on, is it a pain in the ass, is it not, and like why? And I agree. I mean, like the thing about CRAN is they don't care about, they're not testing like, are your functions reasonable? They're just testing like, does it pass all the checks? And the checks are like, is your documentation?
Yeah.
I mean,
It's an extra hoop, but the
it
real
is an extra
the
hoop.
real debate is not, is it an extra hoop? It certainly is. The real question is it worth it? And the answer is probably. In most cases. It's good that they have those high standards of coding available. But like I said, the Python community makes it a real low barrier of entry to get in there.
So if I were to be a troll, could I make a sort of empty package and basically just take up all the names and
Like trying to buy URLs and then sell them off to people? Yeah, you could probably spam them with a whole bunch of register requests. Make your millions. I suspect something will happen.
Yeah.
Somebody maintains these servers. Someone will notice your billion requests. And, yeah.
So I have a question.
Please.
What happens if you have a package with more than one module? How do you set up the init file?
If you've got more than one module in your package, no, not like that. So if we go into my package, so we're asking about
So
the.
is that my module and my module 2?
So yeah, you've got a situation where you've got. We'll do exactly what you just said. My module 2.py. It had some extra code in it. I won't bother writing extra functions for this. But in here, you can add more lines. From here, import my module 2,
Okay.
et cetera, et cetera.
So I just Googled it, and they some people say all with square brackets for putting in all the modules together.
That's really neat. I didn't know about that.
Well, I don't
Okay.
know, just-
There's usually a whole bunch of different ways to do stuff. So yeah, if there's like an import all, like is it like import asterisks or import all in
Yes,
square
it's got
brackets?
Those.
Yeah. So there's all kinds of different ways to do it. I am kind of a control freak, so I like to explicitly say I want this and nothing else, so that no surprises really happen. But maybe that's overkill. There's nothing wrong with importing everything like that. Question?
I have a question. So Matt and I and you also have this file. What's it called? Yeah, it's got a C at the end.
Init Pike and my module Pike.
I see. Pike.
Or-
PYC.
Yeah.
And what is it?
What is it?
I deleted it because I thought that I made a typo.
No, you didn't make a typo.
So you just combined.
Let's have a look. What is it? Oh my God, what is that? That is gibberish. So this is the sort of compiled, like the pre-processed Python that Python actually executes. So when you do Python myfile.py or whatever to run something, it doesn't just explicitly run that. It digests it into a Pike file and then runs that.
Okay.
And you'll notice you can still, the only readable parts are the comments because there's nothing you can boil a comment down into, right?
So
There's no optimization for comments. Never be afraid to remove those because every time you run your stuff, you can it'll just regenerate it again. So I'll kill it, and then if I ran an analysis again, it would all come back. Really common thing to do if you're familiar with git ignore files for GitHub fans is star.pike to make sure none of those actually get to GitHub because they're useless to share with people. More questions, more comments? We're at 2 o'clock.
Can you just go back to how you actually made the package with the task?
Yeah. Here, I'll put it in the Etherpad here, just so you've got notes of it.
So what is that? So that makes the task one.
Yep.
Whatever, and then also installs it into your machine.
It doesn't install it right away. You'd have to do like an install step to install that
Okay,
as
so it
well.
makes them-
Yeah. So normally to install it, what I usually do if I intend on distributing a package is I'll make the tar file, push it to PyPy, and then sudo pip install that package.
And you can't use the task file unless you install it.
Yeah, you do have to install it. You don't have to install it from PyPy like that. You can do it locally. I just never do because if I'm making a package, the whole point is because I want it on PyPy. And then by going through the whole workflow of pushing to PyPy and getting it from PyPy, I see that it actually works for third parties that are going to do that same thing. That's why I like to do that. But again, not mandatory. You can do it on your own. Actually, rather than typing it out again, all the notes in all their glory are in this lesson, which I'll put a link for both in the notes here, right there, and it'll also go into the GitHub issue as well. So you can go through the whole thing in exacting detail if you missed any steps.
Yeah. So like,
What's going on over here? Share with the class.
with the class, right?
Yeah.
So basically spent the last hour setting up Python on this computer.
Yeah.
And Python works like it's in the path variable and everything, except when I pip install things, I get a bunch of gibberish saying that there's not a bunch of dependencies that are not linked and stuff.
How did you install Python?
Through the installer, just for Windows.
Yeah. My number one advice for getting Python set up the first time is go Anaconda. Anaconda is awesome because it has all that stuff all figured out for you. Yep. Make your life easy. I think it comes with nose and everything else that you could ever possibly hope to have with Python. That's kind of, yeah, it's really convenient. More questions, more comments before we wrap up? Going once? Going twice. Okay, that's packages in Python.
Fail.
My pleasure. So next week, quickly go through the schedule here if I can find it again. Here it is. Next week, we've got a co-working session, and it is next door through that wall right there in 225. So for those that haven't come before, our co-working sessions, we don't have like a lecture like this. We all just get together, bring our programming projects, and work on it for a couple of hours and understand that we can all ask each other questions, help each other out with what we're doing, just share what each other are working on. You get this many people together around a table working on projects, I guarantee each and every one of you, you will meet someone that is working on something similar to what you're doing, that you maybe get some help from, or at least have a useful conversation with. That sort of cross terms, super common. So that's what we're doing next week, 1 o'clock through the wall. 1 week after that, 2 weeks from today on February 1st, we were gonna go back to R, and we were gonna learn about assertions in R from this gentleman, from Andrew.
Yes.
Andrew, do you have any comments on that lesson coming up?
No, although if there's anything in particular who wants to learn about them, let me know. The thing I'm interested in is learning how to test data. So when you're reading in a bunch of files for your analysis to make sure that what you think is a number is actually a number, and is it within a sensible range for those values? You know, if it's a height, it can't be negative. If it's a count, it can't be non-integer, that kind of thing.
So also that is relevant to this lesson we just had today, because I blew right through testing in Python super fast in this lesson. But you saw, remember I did assert this equals that other thing to check my function? Well, Andrew's gonna go through assertions in exacting detail. Now it'll be in R and not Python, but the logic is the exact same thing. You're checking to make sure things are what you expect. So still super useful. Last bit of advertising before we wrap up. If anyone is new to R, and would like to learn some R, we have an R software carpentry workshop coming up at the end of the month. It's a 2-day workshop for introducing programming skills for scientists. So yeah, that's going to be, I think, on the, the 28th and 29th, or 29th and 30th.
It's Friday and Saturday.
Friday and Saturday, yeah.
Okay.
Yep, that one, 29th and 30th. So yeah, that's linked off the website too, probably.
Can I just plug the February 22nd co-working session?
Yeah.
As a potential time when we're going to do the text editor fashion show, potentially, as a course event, if people are keen on it.
Yeah.
I'm very interested to see how other people use their favorite text editor, and it's right. It's like a well-known stereotype that everyone has very strong feelings about that. So I just thought that while we're co-working, we could take turns at the projector, just sort of like whatever, indenting things as a blind text. Or
absolutely, that's going to be tons of fun. So we're going to, like Andrew just said, show off all our different text editor tricks.
So if
Yeah, so right.
so,
Using
you know,
our studio in its default.
Exactly. we've got an issue going, so you know, whatever.
You've inspired me to
Shine it.
You've inspired me to actually learn something about how to use my text editor rather than just slapping buttons, which is what I do so far.
More attractive notepad.
Yeah, exactly.
Nothing wrong with that.
Can I, so I wasn't here when this was all filled out, and
Yep.
so I had proposed doing
A leaflet session.
Yeah, doing leaflet and shiny. So I have I've just finished a reading, I think.
Yeah.
And so I'm perfect. I'd be very happy to share that with people, but I don't know if we want to replace one of the co-working sessions.
Yep, we could definitely do that. Yep.
So whenever is good, basically,
So-
except. Sorry.
And while Simon figures that out, the zoomed out version of this is we have a ton of events coming up this semester. Look at them; they're on the website. So check them out. Come to the ones you're interested in. That's it. Thanks, everyone. See you next week.
Great job. No, I would, yeah, it's a good one. So you use it for simulations? Yeah, that's what I did.
Can you go back to that? To the co-working. Oh no, that's cool. Session.